Okay, so the next question number 12. It says two A.P.s have the same common difference. So there are two A.P.s. So let's say I have this one AP1 and this is AP2. Okay, there are two A.P.s. They have the same common difference. So this is small d and let's say this is also small d. The first terms of the two A.P.s, let us say for this A.P, I call the first term as, I denote it by A, and for this A.P, I denote it by the symbol B, the first term. So two A.P.s have the same common difference. The difference between their 100th terms is 100. So difference between the 100th term here and the 100th term here is given as 100. So how do you find the 100th term here? It is denoted by A100. Okay? And how do we find the 100th term for the second A.P? It is B100. Because we are taking B as the first term. So instead of, if we are taking A as the first term, we call it A100. If we are using the symbol B for the first term, and to find the 100th term, we use the symbol B100. So they're saying the difference between their 100th terms, so the difference between their 100th terms is 100. So this is your equation. A100 is, we use the same formula. An is A plus n minus 1 into d formula. So A100 becomes A plus 100 minus 1d, which is 99d, minus brackets. B100 will be first B plus n minus 1, which is 99d. The common difference for both of them is the same, but the first terms are different. So this is equals to 100. Alright, I hope this is clear. B is the first term we are taking for the second A.P. We are just using a different symbol because we've already used the symbol A in case of the first A.P. Okay, so we're using the same formula An, which is A plus n minus 1 into d, where A is the first term. So this is what we get here for A100. B100 means the first term plus n, first term we are taking as B, plus n minus 1 meaning 99 into the common difference d, because the common difference is the same for both of them, is 100. We simplify this equation. So A plus 99d minus, I open the bracket so signs will change inside. It will become minus B minus 99d is equals to 100. So you observe 99 plus 99 minus 99 will cancel out. What you're left with is A minus B is equals to 100. So what is the difference between their 1000th term is the question. So using what is given, we have got this result. Okay, the question is, what is the difference between the 1000th term? So A1000 minus B1000 is what we are supposed to find. Alright, the 1000th term of the first A.P. and the 1000th term of the second A.P. we denoted by B1000. So what is A1000? Again using the same formula, A plus n minus 1 into d. So A plus will become 999d minus, put the brackets, B1000 will be B plus 999d is equals to, we need to find the value. So we simplify this, this is equals to, if you simplify, if you open the brackets, what do we get? Minus B minus 999d. So plus minus cancels out. You are left with A minus B. The difference between the 1000th term we get is A minus B. But if you observe, A minus B value we have already found, which we just substitute. So A minus B is 100 as well. So if you observe, the difference between the 100th term or the 1000th term or any other term, difference between their even 50th term, you'll observe it will be the same, 100. Alright. Next question, number 13. The question says, how many 3-digit numbers are divisible by 7? So we're talking about 3-digit number. Now 3-digit numbers, they start from 100 and the last 3-digit number is 999. But there is a catch. It says the 3-digit number which are divisible by 7. So what is the first 3-digit number which is divisible by 7? It starts from 100, yes, but we check if it is divisible by 7 or not. So if you check, when you divide it by 7, what is the remainder? 1's are 30, it becomes 4's are 2 is the remainder. Okay, so if you add 5 more, so 2 plus 5, it becomes 7. So 200, I'll add 5 more. 2 plus 5. The remainder, what we were getting for 100, 2. Plus, if I add 5, it will become 7. So this number now is going to be divisible by 7, which you can verify. 105, if you divide it by 7, you get 1's are 7, 35, 5's are, so 15 times basically. It is divisible. So this is the first 3-digit number which is divisible by 7. Which is the next? We add 7 to it, so that will give you 112. Then the next is 119. So this is the sequence. Okay. Now, as we said, 999 is the last 3-digit number, but is it divisible by 7 or not? So 999, if I divide by 7, what is the remainder? So here, if I divide 1's are, it will become 29. 29 means 4's are 28. 19. 19 means 2's are 14. So 5 is the remainder. So 5 is extra here. Okay. So 5 is extra. So if I subtract 5 from 999, that number is going to be divisible by 7. So 999 if minus 5 is 994, which you can again verify. If I divide 994 by 7, I'll give you 1's are, then 29 means 4's are, 28, 14 means 2. So yes, 994 is divisible. If you add 994 plus 7, it is 1001, which is a 4-digit number. We're talking about just the 3-digit numbers. Okay, so this is the way we form an AP using this statement. How many 3-digit numbers are divisible by 7? Using that statement, we form the sequence of AP. Okay, now here what are the known values? A value is known, 105. The common difference value is known, which is 7. Here, how many 3-digit numbers? That means they're asking n value. Okay, and 994 is the last term here of the sequence, meaning the nth term, an, is 994. Okay, so we'll start with using this equation. An, we'll use the formula. So for an, I'll substitute as a plus n minus 1 into d is equals to 994. So in this formula, I know a value, I know d value, and I can find n value by solving this equation. So a is 105 plus n minus 1 into the common difference is 7 is equals to 994. So n minus 1 into 7 is equals to this plus 105 becomes minus 105. So that is going to become 994 minus 105. It is going to become 889. So what do we get? N minus 1 as 889 by 7, which is 1's are 7, so 18. 18 means 2's are 14, 4 is the remainder, 49. 7's are 49. Just a normal division. So n minus 1 is 127. So n becomes, minus 1 becomes plus 1. So we get 128 as the answer. Okay, so the question, how many 3-digit numbers are divisible by 7? There are 128 such numbers. So you see, 105, 112, 119, 126 till 994. There are 128 such numbers which are divisible by 7. Okay? Alright, the next question, question number 14. How many multiples of 4 lie between 10 to 250? Lie between 10 to 250. Multiples of 4. Okay, so after 10, which is your first multiple of 4? 12. And the next multiple of 4? 16. 20. Dash, dash, dash. The last number is 250. So 250, if I quickly check by 4, what is the remainder? So 25 into 6 is 24. 1 is the remainder, it becomes 10. 4 2's are 8. So 10 minus 8 gives you 2 as the remainder. That means from 250, if I subtract 2, the extra remainder, that number is going to be divisible by 4. So 250 minus 2 gives me 248, and which you can verify. 248 by 4. If you do, you'll get 62. Okay. We're talking about number which is lesser than 250. So between 10 to 250. So after 10, this is the first number, and before 250, this is the last number which is divisible by 4. So they're asking how many multiples of 4. That means they're asking n value. N is not known. What is known? A is known, which is 12. Common difference is known, which is 4. And 248 is your nth term. An is known, which is 248. This is the last term, which we call as the nth term. Now, we can use nth term formula, an, which is a plus n minus 1 into d. So, a plus n minus 1 into d is 248. So, in this formula, we know a value, we know d value. So, we can simplify this equation to get n value. So, 12 plus n minus 1 into d value is 4 is equals to 248. This is plus 12. Plus 12 goes to the other side, becomes minus 12. So what do we get? N minus 1 into 4 is 248 minus 12, which is 236. So n minus 1 will be 236 by 4, which is going to give you, when you divide 236 by 4, it will give you 5s are 20, 36 means 9s are 59. So n is 59 plus 1, which is 60. So this is what we are supposed to find. The question is how many multiples of 4? That means there are 60 such multiples of 4 between 10 to 250. I mean 12, 16, 20, 24 till 248. There are 60 such numbers, 60 such multiples of